So now we're going to transition and move on to Dr. Matthew Plow, who received his PhD in 2006 from the University of Minnesota in the area of rehabilitation science with a sub-concentration in behavioral science. He completed 2 postdoctoral fellowships, one at the Center for Gerontology and Healthcare Research at Brown, and the other at the Department of Occupational Therapy at the University of Illinois. After completing these postdoctoral positions, he worked for 2 years at Cleveland Clinic as project scientist in the Department of Biomedical Engineering. And Dr. Plow is currently an associate professor at Case Western Reserve University. His research interests are in identifying, optimizing, and disseminating tailored self-management interventions to reduce the devastating effects of disabling conditions on quality of life. He's published numerous studies and book chapters on fatigue, physical activity, and wellness promotion in people with multiple sclerosis. And Dr. Plow has received continuous grant funding since graduate school from an array of funding agencies, including NIH, Department of Defense, Patient-Centered Outcome Research Institute, Consortium for Multiple Sclerosis Centers, and National Multiple Sclerosis Society. Today he'll be talking about, his title is Understanding Fatigue in People with Multiple Sclerosis Using Ecological Momentary Assessment. So Dr. Plow, go ahead and take it away. You can share your screen and your video if you'd like. And thank you for joining us.
Yeah, thank you for having me. Let's see, share screen 2. All right, can you see my presentation okay?
We can. Yep.
Okay, wonderful. Well, I just want to say thank you for having me, and also thank you for the LifeData and Kevin for organizing this symposium today. It's certainly a nice break from our everyday routine that we're now experiencing indoors all the time. So I'm going to be talking about multiple sclerosis and fatigue today. I first kind of want to give an overview of basically the premise of the research that I do. It's really focusing on this disabling cycle and trying to understand this cycle and trying to break this cycle. So a lot of my research is focused on MS and neurological conditions and thinking about ways to promote health and wellness in these conditions. So essentially what happens, we see a lot happening, you present with these symptoms and impairments and disability. This results in difficulty engaging in healthy behaviors, which leads to deconditioning, obesity, and activity, which results in secondary conditions. And then this results in more symptoms, more impairments, and more disability. So this is just a vicious cycle that goes around in a circle. We see this a lot, particularly right after, within a year or two after diagnosis with one of these conditions. So if we can understand ways to help break this cycle, and promote engagement and healthy behaviors, understand the factors that promote healthy behaviors, hopefully we can prevent some of the cycle from occurring. So first, some background on multiple sclerosis. Nearly 1 million people in the United States have multiple sclerosis. It is an immune-mediated disease. It's basically a fancy name for a special type of autoimmune disease. It has a very unpredictable disease course. So when you get diagnosed with MS, the neurologist essentially tells you that, you could possibly be using a wheelchair within a couple of years from now, or you may have symptoms that have a relatively low impact on your daily life. So you can imagine that unpredictability is very difficult to cope with. It is much more common in females than males. It's almost a 3-to-1 or 2-to-1 ratio. Symptoms include fatigue, muscle weakness, spasticity, mobility impairments, cognitive problems. I mean, again, it just all depends on what nerves are being attacked in the central nervous system. So the symptoms are very wide ranging. And so it does make it a good model to understand and generalize to other conditions as well, because they do experience such a wide variety of symptoms. Fatigue is one of the most common symptoms in MS. Almost up to 95% of people with MS will experience chronic fatigue. And 60% of it will call it their most disabling symptom. There's both mental and physical components to fatigue. Up until 10 years ago, we all just talked about the physical aspects of fatigue, but we're now realizing, there is a mental aspect to fatigue as well, and it's significantly correlated with cognitive impairments as well. So definition of fatigue and multiple sclerosis, there's a wide range of definitions. So, I just want to be consistent. So when I'm talking about fatigue, everyone is on the same page with it. Essentially, it's a lack of physical or mental energy and an overwhelming feeling of tiredness and exhaustion that is perceived by the individual or caregiver to interfere with their usual and desired activities. So I think the key here is usual and desired activities and preventing and interference with those usual activities. So, we all experience fatigue, but when it starts to present with interfering with your usual and desired activities, then it starts to be a problem, and then we call it a chronic problem. And it's very different from how healthy people experience fatigue. It has a long recovery time. It comes on quickly. Even after a good night's rest, you can wake up the next day and still feel tired. Stress exacerbates, and so does cognitively demanding activities. And it's not just depression. There's been a lot of research, and we can separate the constructs from depression and fatigue. So there is some overlap, obviously, between depression and fatigue, but they are different constructs. Causes of fatigue are really unknown. There's some consensus around there's multiple factors that are contributing to fatigue, and not just in mass, even within the healthy population, people that experience, chronic fatigue syndrome and other types of fatigue issues. There's not one thing that we can pin it on. Typically what we do in the research literature is we divide it up into primary and secondary causes of fatigue. And so primary causes are basically due to the disease itself, the physiological nature of the disease and the ramifications of it. And then there's the secondary causes as well. And so that's associated with due to other symptoms and also behaviors as well. So for example, primary causes of fatigue specific to neurological conditions in MS, it could be around lesion loads, how many plaques you have on your neurons, axonal damage, adaptation, your nerves are essentially having to work harder, peripheral nerve muscle damage, inflammation, and the poor sleep quality as well. Secondary causes are not necessarily specific to the pathology. So for example, depression, poor sleep hygiene, medication side effects, comorbid conditions, mobility impairments. I mean, the idea is if you're having to spend more energy with walking and mobility, you're going to get more fatigue. And then other conditions such as arthritis and cardiovascular disease all can play a secondary factor in contributing to fatigue. So the premise of this study was, thinking about how we can characterize fatigue better, particularly within people with MS. So when you think about fatigue, we can think about the severity and the type of fatigue. Is it a cognitive fatigue? Is it a motor fatigue? Is it co-occurring with other symptoms such as depression, anxiety, cognitive impairments, and pain? And then its impact on life situations. So we're really trying to make the distinction between the severity of the fatigue and the impact of fatigue on your life situations or your daily activities. Lots of prior studies looking at fatigue view it as a single subjective entity that does not fluctuate over time. And so hence the rationale for using EMAs. Most of the research up to date has used recall-based measures. And so they don't get a sense of how it's fluctuating throughout the day and over the course of a few weeks. Fundamental questions remain then, are there clinical subtypes of MS fatigue? Can we identify a particular fatigue phenotype, so to speak? So, maybe some people, have experience fatigue only in the morning, or some people only experience fatigue late in the evening, or they have this cycle of kind of going up and down across the day. So that was something we could look at, and we could utilize EMAs to start looking at some of those patterns over time and to see if there's any consistent patterns. The treatment, I'll say this, the treatments for fatigue are not very good. There's no FDA-approved medications for fatigue right now. So the idea was if we can start to better characterize these fatigue phenotypes or patterns of fatigue over time, maybe we can start to identify and tailor treatments better to the type of fatigue people are experiencing. So this was essentially the model that we used for the study. It was based on the International Classification of Function. It's a common model used in rehabilitation science. Essentially, I think that the highlight here to take away here is there's a fatigue impairments and severity, which is under body function, and there's also fatigue impact. And then in the middle there, you have your activities that are thought to, your intermediate variables that are thought to influence these two. So, I always use the analogy of pain. Some people have a very high pain threshold where other people don't have that threshold. And so, a pinprick puts them out of commission, and they're unable to do their daily activities, where other people can have extremely high threshold of pain and still go on with their daily activities. So we think the same thing is true about fatigue. And so the idea being, if we can identify these intermediate factors and modify them, perhaps we can maybe not reduce the severity of fatigue, but reduce the impact on daily activities. So if we can think about how we can change the psychological aspects and both the behavioral aspects of it, even though the severity of fatigue may be there, we may be able to reduce its impact on daily activities. And then, of course, there's also environmental factors and personal factors in there too, such as self-efficacy, demographic characteristics, society barriers. Those can also have an influence, a direct influence on your activities, which some are maybe modifiable and others are not modifiable. So the aims of this study were to characterize fatigue phenotypes. We were doing a cluster analysis for that particular aim. Then we also examined how activities, basically these intermediate factors, and how these intermediate factors influence the relationship between the severity of fatigue and the impact of fatigue on daily activities. And then we also wanted to explore the relationship between fatigue impairments and fatigue impact in a subsample of people of 120 using the ecological momentary assessment. So there was very little data when we first did the study about the feasibility of doing ecological momentary assessment. So we were a little reluctant to propose that for the entire sample. So essentially what we did is we selected 120 people. We actually did it in a randomized sequence to either receive the EMAs or to receive the EMAs and the recall-based measures, or just to receive the recall-based measures. So all 300 participants received received the recall-based measures, and then 120 participants received the EMAs as well as the recall-based measures. So we did this longitudinally. We took the recall-based measures at baseline, 6 weeks and 3 months. Again, all the surveys were completed online. Then 120 participants also wore an accelerometer, an activity graphics accelerometer, and then completed the EMAs. Essentially for the accelerometers, this was also a new method that we were trying in the study, that essentially we would have them wear it on their waist during the day to measure activity levels and the intensity of activity levels. And then we asked them to put it on their wrist at night so we could also measure sleep, because we weren't aware of any algorithms that were validated for wearing it on the waist during the night. So we had the participants switch it up. Up until this point, a lot of literature had divided it. You either were wearing it on your wrist at night or during the day for physical activity. So there weren't many studies guiding us on how to kind of switch the accelerometer from the waist to the wrist and how to do those types of analyses. So we are still trying to figure that out as we go along here. So in terms of the EMA methods in the 120 participants that we did, we basically bothered them, chimed them 5 times a day randomly within the following windows. And then we asked the following 5 questions. How fatigued do you feel right now? What were you doing right before the beep went off? And again, we were struggling with what to include in these types of things. We had kind of 4 main areas that we wanted to focus on, and then the other button. And actually, when you push the other button, there was a few more areas, and then also basically a box where they could enter something in as well. How much fatigue is interfering with the activity you're doing right now. And then we also added 2 additional questions about how happy you are right now, and then how stressed are you right now. And so we asked all 5 of these questions 5 times a day for 10 days straight. And then we did that at baseline, and then we also did that again at 3 months. So in terms of feasibility, the results that we got, we were very happy with our response rate to this study. We screened about 394 people and then randomized the 300 participants into the EMA group or to just the recall-based group. At the time, we just wanted a way to select participants to do the EMAs that was fair and equitable, because they got paid a little bit more, so we decided to randomize. What that did do, though, was allow to look at the response bias and look at the influence of the EMAs with the people filling it out compared to the people they didn't fill out on the recall-based measures. So that was some interesting results. I'll get to that next. In terms of the recall-based questionnaires, we had 86% complete them at all 3 time points. EMAs, we had no clue how that was going to turn out, but we had very good response rates. So 91% of the participants completed the baseline EMAs with no missing data, and then 88% completed them at 3 months with no missing data. So we were very happy with those results. What we found were either participants did them or they didn't. If they were either dedicated to answering it the 5 times a day or they didn't do it all. They may have downloaded the app, but then they didn't start to fill them out at all. So in the future, I think we should identify those people early that downloaded the app and then don't have any responses for that first 1 or 2 days, and we should be following up with them a little bit better than we did in the study. But overall, still very good response rates. So we've had a ongoing theme with a lot of the presentations about response shifting. And so we were able, because we randomized people to the EMA versus the non-EMA, we were able to look at the recall-based measures. And we must have run we administered probably 10 to 15 different recall-based measures, comparing the people that did the EMAs versus the people that didn't. And we found no significant differences on the recall-based measures. So we did not find any evidence of response shifts, and we asked a lot of recall-based measures. So fatigue, depression, anxiety, physical function, well-being, and mental function. None of those measures were influenced by completing the EMAs. So that was a little bit of a surprise for us. I mean, you think with the amount of statistical tests that we ran, we would have gotten at least 1 significant differences, but all of them were very stable, and the EMAs didn't have any influence on these recall-based measures. And the test-retest reliability was adequate. When we looked at, from the first day they filled them out to that 10th day they filled them out, the ICCs were above 0.7. So that's another good implication. So, I think one of the things we're going to start exploring is whether we can start using these as outcome measures in clinical trials. Both these lines of evidence in terms of the test-retest reliability being stable and not influencing the recall-based measures. The old saying, if you measure it, you change it. That may be true, but not. We're not seeing any significant evidence of this when they're completing the EMAs. We also did a regression. So looking at the regression model, we were very happy with the regression model. We were able to explain 52% of the variance within fatigue impact. Essentially, the variables that were included in there were self-efficacy, environmental factors, cognitive impairments, walking ability, sleep quality, and fatigue catastrophizing. The strongest predictor was cognitive impairments. Was a little bit surprising to us, but that's something we need to be moving forward with. And whether it's the cognitive impairments causing the fatigue or the fatigue causing the cognitive impairments is something we'll have to work out in future studies. Interestingly enough, variables that were excluded that didn't make the final model were things depression, anxiety, pain, and fatigue severity. That was a pretty cool finding about the fatigue severity not influencing the fatigue impact. So that really supports our model, thinking about these intermediate factors. And so once you put these intermediate factors in, the fatigue severity goes away and no longer predicts fatigue impact. So that speaks well to developing these interventions that are targeting these intermediate factors. And also it was a surprise that depression, previous studies have found depression highly correlated with fatigue. But once we entered these intermediate factors in here, depression was no longer a factor in influencing fatigue impact. We also did a mediator analysis, and this also helps explain some of the results why fatigue severity wasn't influencing fatigue impact. So we essentially did a mediator analysis using a bias-corrected bootstrapping technique, looking at the confidence intervals, and we found that self-efficacy, fatigue catastrophizing, sleep quality, and walking ability all were mediating variables. And so what do I mean by mediating variables? So you look at this model here. So the independent variable is fatigue severity and your dependent variable is fatigue impact. And so those variables on the top there are the self-efficacy, fatigue catastrophizing, sleep quality, and walking ability are intermediate variables that can help explain the relationship between the severity and impact. And so when you include those variables in the model, the relationship between severity and impact goes away. Well, what are our long-term objectives with the study? Where do we hope to go with this? Again, we hope to develop a fatigue self-management intervention targeting some of these intermediate variables. Obviously, looking at ways for sleep quality. Fatigue catastrophizing is essentially thinking about how you frame fatigue psychologically. Do you think it's the end of the world when you experience fatigue, or is it something that's not a big deal? So if we can kind of frame that, how people think about fatigue, that may reduce its impact on daily activities. And then walking ability. If they're wasting a lot of energy walking around, they're going to have obviously more fatigue impacts. So thinking about how we can use mobility equipment to essentially improve walking ability or help them conserve energy so they can do other activities that are meaningful for them. So it's along the lines of developing a fatigue management intervention. We want to eventually start to incorporate machine learning to develop a fatigue gauge or battery. So essentially battery to tell people how much fatigue they are experiencing and when they're going to hit that wall. So lots of times what we see with people with MS is that they overdo it and then they hit a wall and they're wiped out for 3 or 4 days afterwards and they're not able to do any of their daily activities. So if we can help prevent that wall by promoting activity pacing. Right now, it's typically done by education and there's not tailored to the person at all. They're just giving general advice. So if we can give them specific advice of when they should rest, and not just rest, but also engage in activity as well, right? Because if we just promote the resting aspect of it, deconditioning is going to be an issue. So trying to find that balance throughout the day. So we framed for the DoD, we framed this project, looking at how we're going to develop this fatigue gauge. Aim 1 was to think about how much energy we're going to assign to each person. And then Aim 2 was thinking about what factors influence the energy bar, and then how to tailor the messages was essentially with Aim 3. Again, so we're slowly starting to develop the prototype, the visualization of the energy level. So that's an example using the smartwatch there, looking at the battery. Right now, it's very simple. We're just basing it on the step counter, and it's actually doing pretty well just looking at their step count. So the number of steps they get throughout the day, and that's corresponding to the fatigue gauge. That's working fairly well. I mean, obviously we're gonna have to start having much more sophisticated algorithms running in the background to have better prediction, but just with the step count alone, with proof of concept, it looks fairly encouraging. So the idea being is that we can, throughout the day, as they are expending energy, we can provide them with text messages of when to prompt rests and when to promote physical activity. And then, as we move along with this research, 52% of the variance explained in fatigue impact is pretty good, but for machine learning algorithms, you need a lot higher increase in accuracy there, particularly when you're dealing with an individual and trying to provide advice specific to that individual. So our future studies, we're thinking about how we go about increasing the accuracy of the predictions. Acknowledgements, this was funded by the Department of Department of Defense. I think they're interested in the study, obviously for the fatigue and the outcome of looking at some type of smartwatch app where you can measure fatigue and also let people know when they're overly fatigued. That's my research team, and then acknowledgement of my conflict of interest. I don't have any besides my wife, dog, and son there. And then I'm open for questions.
Great, thank you so much, Matthew. I had a question about the incentive. You mentioned paying your participants, and I was curious as to the amount and if you paid for the overall study or per response. And related to that, how many questions were you delivering per time point?
At each time point, we were delivering 5 questions. Let me go back to that slide. Yeah, so we were at each time point, so there were 5 time points, and each time point we're delivering 5 questions. Now that question number 2, if they selected that other, or they selected physical activity or exercise, there was two follow-up questions that we asked afterwards. So we're thinking it took them about 5 to 10 minutes to fill them out at each basically time point we chimed them. In terms of pay, I don't remember the exact amount, but we did pay per response. We figured we'd get a little bit better response rate if we paid by the response. I think we paid, I don't know, I think it was $1 or $2 per response they actually had. So that would give them incentive, not just to do it once throughout the day, but to try to do it as many times as they can throughout the day.
Yeah. Yeah. Thanks. Yeah.
Yeah.
So what are the kind of lessons? I mean, you've spoken about that a little bit. What are the kinds of lessons you've learned in this your EMA study for future study? Any words of wisdom when considering kind of EMA, and kind of the things to watch out for, or the things that you've learned?
Yeah, the technology piece was a little bit challenging. Providing that customer service right away. So if the person was having difficulty, they could call into essentially a 1-800 number line, and we'd have someone there to provide tech support for them. And I think the people that we lost in the study were the people that weren't technologically savvy. We kept on having to refine the instructions as we went along with the study. We finally ended up having a Word document with pictures on it, pointing to what you had to click on to download the app, to upload the right life pack and everything like that. And we refined that as we went along. So I think probably one of the things to test out those instructions before you actually implement the study. And so you have kind of and you get feedback from participants. So you're almost doing a trial run and you're getting the feedback from participants right away. And then looking early, I mean, it was pretty clear that we had a group that, did everything or they didn't do anything at all. So really thinking about those people that didn't do it all and identifying those people early on and then trying to get them engaged in the study.
Yeah, thanks. And you noted that depression didn't significantly add to your model and account for any unique variability. What accounted for that? Was it the inclusion of self-efficacy and catastrophizing, or?
Yeah, catastrophizing was a big one there. It was, when we just used depression in the model, obviously there was a strong correlation. The bivariate correlation was very strong. But once we started introducing self-efficacy and some of these other kind of intermediate variables, depression went away.
Okay.
So it was these intermediate variables that kind of trumped the depression, so to speak.
So I think we have one last question here. This person's wondering if the pandemic will have an impact on your study, or if you.
Yeah, so I would love to do a pre-post. This was all pre-pandemic. It would be very interesting to do this study again, particularly around those questions around stress and happiness. So we're looking to obviously do that again. And so we're looking for some funding now to be able to do something post to compare the data with pre. But yeah, I'm sure it's going to have implications about how some people are responding to these questions and thinking about what activities they're currently doing.
Great. Well, thank you. Thank you for sharing that and introducing machine learning. I'm interested in that as well as that goes forward. Appreciate your time, Matthew. So we are at our break. So we'll now take a 30-minute break. This is a time, so get something to eat, maybe something to drink, maybe get some of that exercise we've been talking about that can actually decrease fatigue. And also we apologize if the queue for the restrooms are a little long. We've had more attendees than expected, but please try to be back to your seat by about 12:10 Eastern time, and we'll set things up and get going with our keynote, Roy Baumeister. So thank you all for your attendance and participation, and see you back here at 12:10 Eastern time. See you soon.